All right, good morning, everyone. Welcome back. We're here to talk about DRM today. I think this may be the first time that I'm ever talking about DRM at Streaming Media, so I'm kind of excited. It's also, I think, reflective of the fact that we're starting to talk about monetization in OTT. A lot of us used to be worried about, well, can we do live and can we scale and can we deliver, and can we do device reach? And now that all of that is solved, let's actually start making some money on this thing. So we're going to be fairly interactive, or we're going to try to be. If I'm talking too quickly, as I'm known to do, just flag me down. And if you have questions at any point of time, also please flag me down. This is meant to trigger an interactive discussion, hopefully. It's very unlikely that everyone will agree with everything that I'm talking about today, so let's have those discussions. That's why we're here. With that, the only other caveat I will say is that all the opinions here are mine. I have stolen slides and material from multiple sources, mostly with permission. But if you see any conclusions being drawn, they're not representative of anyone except me. All right, so HTML5, media extensions, common encryption, they all bear the promise of moving away from the alphabet soup of HLS, HDS, CBC, pattern encryption, all the different streaming standards, compression standards, encryption standards, DRM systems that we've had. Is it really going to nirvana or not? We'll see. I think that's the intention. And this is definitely the largest leap forward we've seen since about 2000 when I first started tracking this space. So there's good stuff. Why should you listen to our opinions? We're the digital media team at Frost & Sullivan. We cover a fairly wide variety of markets, all the way from camera to rendering, what we like to call glass to glass. And so our perspectives are drawn from a number of different sources at various points in the value chain. I cover at Frost & Sullivan content protection, encoding, transcoding, workflows, and delivery. So even from my point of view, I look at it from several different perspectives. And over time, we found that that tends to give us a fairly good handle on what's happening and what will happen in the market. So we'll do a quick look at DRM 101. This is not so much here's how the private keys and public keys work, as it is here's the philosophy behind DRM, and let's not forget what we set out to do. We'll talk about the motivations for why interoperable secure playback is such a big deal and why so much effort has been going into it. Also, why you need to embrace it within your business plans, within your workflows, whether you're a content company or a tech provider or a value-added reseller. We'll talk about some disruptions, options, solutions, recommended best practices, and conclusions. This will not be a talk where we talk about the mechanics. Sorry, thank you. This won't be a talk where we go through the mechanics of DRM. So we're not going to talk about key exchange protocols. We're not going to talk about rights expression languages. We're not going to talk about what happens when a certificate is revoked. The emphasis is mostly on OTT content. So yes, there's Blu-ray discs and there's digital cinema, and DRM comes in many, many varieties and flavors. Our emphasis here is the web. And I'm not also going to go into the specifics of the standards themselves. I do have some links at the end of the PowerPoint. There are some in the room who are far more qualified than I am to talk about exactly how you would implement a manifest, or how you would do a CDMI implementation, or how you do common encryption. This talk is really to put all of those in context of real-life application scenarios and market landscapes. So before we get started with anything, and my colleague Anisha will run a mic around the room, how do you define DRM? Someone raise their hand.
Oh, I would say a system to protect your content.
A system to protect your content against?
Against
illegal playback. Okay, okay. Eric, you want to take a shot?
I thought it was going to be kind of funny, but protecting your marketing budget.
Yes, protecting your marketing budget, absolutely. Absolutely, you need ROI on your content. All right, the popular perception of DRM is that essentially it's a revenue protection tool, it's a content protection tool. I will argue that a DRM system is actually 3 layers. It's a mathematical core where there's a lot of cryptographic magic happening of various kinds. It's wrapped in trust. It's wrapped in an application that is translating the trust that the copyright owner put in the service provider, who put in the DRM platform vendor, who put in the secure player vendor. And you're trusting that the user who's consuming the content is doing so in an authorized way. And the goal is to bring a protected business model to life. You're protecting your marketing budget, you're protecting your content against, you have to balance the supply and demand. That's really the only way to monetize content. In that context, a DRM vendor becomes a trusted business partner. If you're a content service provider, I'll argue you have some more leeway in switching DRM systems. If you're a vendor of smart TVs, the DRM system that you put in on day one is the same one you're going to have 5 years down the line. So you're architecting something that you'll ship today, but will be protecting content and consuming content, hopefully 5 years down the line. If you fail to do that, you're going to devalue your brand over time, because guess what? This television doesn't process 4K content. Guess what? That Blu-ray player can't play the disc back. Oh, this streaming media device got bricked because the private key was stolen and now it can't get any new content. The UX suffers dramatically when DRM malfunctions, and it can malfunction for a number of reasons. Almost none of them are related to the technology. They're always related to the implementation. So your DRM vendor is a business partner, and they ideally will work with you from design through implementation, past maintenance, and into renewability. And you really want to keep that perspective in mind. I look at piracy as imperfectly controlled distribution. If you intended for your video to be freely and virally distributed, that's not piracy of the video, that's intent. When it's imperfectly distributed, if it's played in the wrong resolution, up or low, if it is played in regions it wasn't supposed to play, if it's being played past a 24-hour window, any kind of imperfect distribution, in theory, is piracy. And you can lose more than just control over the content. You could lose ad revenue, you may lose subscription revenue, you may have underpayment of subscription revenue, you may have loss of transaction revenue. All of those are leakages to the budget that you want to worry about. And finally, and arguably the most importantly, your user is not equivalent to the pirate. It's very, very important as you're implementing these systems to keep in mind that the user experience, the legitimate experience, needs to be transparent, seamless, high quality, consistent. And it's the pirated experience that you want to hold back on. And this, again, is a business trade-off. So with that context, over-the-top online video content protection takes many forms. You can just do open streaming, make your money off of the ads. The one thing you do want to worry about is if someone's taking your funded stream, putting it on their page and getting the ad revenues instead of you. But other than that, it's open streaming, works fine. Stream encryption is still the most widely used form of content protection. You authenticate once, your live streams are delivered AES encrypted, you decrypt it at the other end. You could screen capture it if you wanted to, you could stream record it if you wanted to, but by and large, this works great for a lot of people. It's lightweight, it's simple, it's okay with the broadcasters who allow its use, it's fine. Digital rights management is what we'll mostly focus on today. These are fairly sophisticated systems that are user-aware, time-aware, place-aware, execution environment-aware, content-aware, output protection-aware. And they are, in effect, understanding, enforcing, and monitoring that the business rules associated with the content license are continuously honored over time. Watermarking and fingerprinting are sort of after the rendering kinds of tools, and they're meant for ongoing trader tracing forensics, just to keep track of the content after it's come out of its encrypted shell. At the end of the day, DRM is a business of trust, and I will argue that the defining characteristic of these systems is its robustness, how immune it is to hacking on day one, and its resilience. When a break happens, and it will happen, absolutely will happen, how quickly can you bounce back? How widely can you bounce back, and what's the cost for everyone involved in dealing with the breach? So encryption is one feature. We talk about content protection, that's one feature. Controlled output, HDMI, copy protection, flagging, link protection, that's one feature. Enforcement of user-specific policies, time-specific policies is one feature. Data reporting for analytics is a feature. We need to start thinking of DRM as more than the encryption solution. It needs to be the monetization solution. it looks at the last inch of execution like no other component in the value chain does. And if you start to think past just the anti-piracy towards the end-to-end monetization, analytics is starting to become a huge part of the overall DRM ecosystem. In terms of elements of a DRM system, and I won't harp this too much more, but you have user-specific authentication, which is also known as public-private key encryption. You have content-specific encryption. So the content itself is always really protected with one or a series of keys, and that's the same for everybody. Whether or not you have permission to get those keys depends on whether you were successfully authenticated or not. You have rights enforcements, you have revocation and renewal. Those are all typically client-side operations with some server-side components. Then you have the output control, forensics, and trader tracing, which is all client-side. And then you have interfaces to billing and tracking, and you have key and license management, which are entirely server-side operations. So there are server-side features, there are client-side features. Again, your end goal is protection and monetization. The whole point of any DRM implementation is to comply with something called robustness rules. And it's important to absorb this for a minute because this will drive all of the rationale behind the standardization, all of the rationale behind the implementation ecosystems, and all the mad trade-offs we see between hardware and software and cost and portability and flexibility that we're going to see moving forward. Robustness, again, I will emphasize, is on day one and continuously over time. So it's robustness as well as resilience. The crux of the specifications is always how hard is it to extract the key, the private key, the decryption key, and the compressed content. Over time, the decompressed content becomes more important as well. But there are, and we'll look at this in a minute, depending on the resolution of content, sometimes you have to, you have more flexibility in how you protect the keys. Sometimes they have to be buried deep in the silicon in a completely dedicated path. The complications of interoperability are different across those different scales. It all ties back ultimately to the robustness regulations that you have. So when someone builds a DRM system, if you have PlayReady or you have DivX or you have, who else is in the room, Azuki, you commit to the studios and the copyright owners that you have a system of a certain level of strength. It's the specification, it's the trust enforcement infrastructure, it's the licensing infrastructure as well. That is then passed on to the service providers, to the CE device manufacturers, to the application vendors, to the licensed service providers, to the silicon vendors who are actually building the silicon that the end systems are architected on. All of these people have a role to play in how the DRM is implemented. And all of them working together ultimately determine how robust and how resilient your implementation is going to be. So service providers rely on a lot of different characters in bringing their service to life. Ultimately, their goal is to run a profitable, popular service. Try not to get sued in the process. Spend the minimum amount that they can, even while maximizing the reach of their service. And that's one of the most critical motivators for why we need some sense of standards, because it's simply not economically feasible to build one by one secure players that are adequately robust and adequately renewable across all the kinds of devices that we're starting to see today. You want to achieve a consistent and pleasant user experience. For anyone who has a screaming toddler wanting to watch Netflix, who's had to update Xbox and then discovered they don't have enough memory so that they have to plug in a USB drive to get the update, to put it on the Xbox, to run it again to get Netflix, knows what I'm talking about, right? Thankfully, we're past those years. DRM has to be secure, but it also has to be pleasant. It also has to be transparent. And that's where the magic of engineering really comes to life. Finally, you want to avoid penalties associated with breaches or non-compliance. These are not $100 fines. They run into very, very large sums. They can make or break a company. And very often, how much you pay for content is predicated on how well you can promise to secure it. So this is a business transaction. It's a wonderful technical problem. We love to be geeks and cryptographists around it. But this is a business technology. It's a business enabling component, and we need to treat it as such. All right, so motivations for interoperable, secure playback. These truths we hold to be self-evident. OTT is a competitive imperative. There is a massive shift away from PC-based streaming. You know, it used to be that 99% of content was on Windows and Internet Explorer. We really didn't have to worry about all this stuff. That's not the case anymore. You have about 8 classes of connected devices in PCs, consoles, streaming media devices, connected Blu-ray players, set-top boxes, smart TVs, a whole bunch of other smartphones, tablets. There are new categories coming every year. There are new vendors coming every year. You know, try to just support a piece of software across that many clients, then multiply it exponentially by trying to make it secure on all of them. There are different operating systems. I mean, there's Android, iOS, Windows, Android, Symbian, Android, Tizen, Android. And you have to deal with all those different flavors. And for many of the streaming service providers here, I know that you're daily dealing with, I don't know, 500 different players. I've heard 2,000 different operating system chipset configurations. It's a complex landscape. And add to that, you have different security tools. So sometimes you have a trusted execution environment, sometimes you don't. Sometimes it's trust zone based, sometimes it's not. Sometimes you have JTAG ports shut down, sometimes you don't. And you have to really look at all those different things as you're building secure players. On top of that, and I'm preaching to the choir here, there's HLS, HDS, Silverlight Dash. You have different kinds of encryptions, different kinds of stuff. If you look at the combinatorial equation, right, and to be an engineering geek for a second, you're taking all your ABR profiles, anywhere between 6 to 12. You're multiplying them with encryption formats. Used to be 3 to 4. Used to be actually 6, and then we came down. Now it's 1, thankfully. There are different streaming formats, and for each streaming format, sometimes you have to encrypt and package differently. This is all happening on the fly unless you want insane storage bills. Then you have to worry about different DRM systems, because some are supported on certain devices, some are not. The security level vary from device to device. And you still want that consistent, pleasing UX, because the last thing you want is a service that runs great on the iOS and won't run on the Xbox. That's how you lose subscribers. So the motivation behind all of this is to put bring enough factors down to 1. So get rid of as many multipliers as you can, first of all, by having the server do the server stuff, having the client do the client stuff, not have them interdependent and talking to each other all the time. And then bring as many multiplicative factors down to 1 as you can. So with the standards, we'll be looking at, there's only one encryption format now. There will eventually only be one streaming format. Ideally, and that ideally comes with a big caveat, you will truly have interchangeable DRM systems. That is a bit of a catch-22, but by and large, we're getting there. The other motivation is, as content resolutions are rising, the level of security you're required to provide, the level of robustness you're required to provide is rising. And the closer you get to all hardware implementation, the higher your implementation costs become. If you have to put 3, 4, 5, 10, 15 DRM systems in a device, you can't make a profit on it anymore. So mostly SD content you can play back in software, and that will be important in a minute. 720p, which is sub-HD, the requirements vary depending on how valuable the content is. By the time you get to full HD, it's almost always at least hardware assisted. By the time you get to HDR 60 frames per second, it's always trusted hardware path, whether it's HD or 4K. So silos have started to give way to standards. For those of us old enough to remember, I clearly am not one of them. We've aspired for interoperable DRM since about 2000. I call it 2080 because it seems like a very long time ago. There was progress. So HBB-TV, which is the hybrid broadband TV, the hybrid broadband standard out of France and UK, settled on Marlin and PlayReady. And yes, there are huge lobbies and a lot of evangelism and diplomacy involved in the industry as well. But on one hand, you had sort of business priorities that were favoring silos. On the other hand, you did have immature technology. And the pain until about a year and a half ago, it was there, but it wasn't as crazy and as crushing as it is now. So come 2015, thanks to the efforts of some very smart people across a number of different companies, we have media source extensions and encrypted media extensions in HTML5. We have common encryption and we have Dash. And then to a lesser extent, but I would argue probably the most importantly, we have the CDM, the content decryption module interface that allows browsers to interoperably connect to different DRMs underway. So this is a stolen slide. John Simmons presented this. John Simmons from Microsoft has been doing quite a bit of work in this area. It just shows how all the different standards connect. So you've got the media source extensions, the MSE, which corresponds to the Dash presentation specification. Then you have the encrypted media extensions, which tells you how you're going to link your player down to the DRM system. And then you have the common encryption scheme, which makes sure that everyone's encrypting content and packaging the packets in the same way so that you can decrypt it the same way at the other end. The underlying plumbing, and I use slightly different terms, so this is the translation map. The HTML JavaScript application, again, remember we're talking OTT content only, so it's almost always going to be a web browser or an app of some sort. That's the player. The player fits into the browser either explicitly or implicitly. That talks to the content decryption module, which I am going to consistently, hopefully, call the DRM client. This is that wrapper of trust around the cryptographic core that's actually implementing the business of DRM. And then you have the actual DRM core, which is all the cryptographic magic, which increasingly is going to run in what we call a trusted execution environment, which is a pristine space of memory and CPU, theoretically, inside the silicon. Now, there are ways that the TE can be invaded. There are other things that can go wrong. But by and large, when you hear trusted execution environment, you want to think secure silicon. I will say that there's an important caveat that perhaps is not as well understood here. I have heard a lot of secure players say that, oh yes, it's HTML5, we'll use Widevine when it's available, we use PlayReady when it's available, and there are other DRM systems that we build on our own that we can put into any device when necessary. You can and you may are two very different things. Okay? You can decrypt doesn't mean you may have the key to decrypt. You may have the key to decrypt does not imply you can decrypt, because if the DRM system is missing on the client, it ain't going to work either. So, grammar is important here. You can because it's standardized. You may because the business relationship is in place. And those two have to come together. And you have to plan for breaches in that connection, at least for the next couple of years until it all settles down. So what's happening with the standards is the content key is exchanged, similar to those who may be familiar with the conditional access systems in pay TV. How the key is exchanged is not standardized. That's a trust relationship. How it's utilized once you have it is fully standardized. That's an implementation situation. So a standards compliant code is irrelevant, again, unless you're allowed to actually use the content on the device, and unless if you're able to finish the transaction to get the decryption key onto the device. And the core and the client, it's important to remember, are two distinct entities. We'll look at the vendor landscape in a second. Most people who provide cores build at least one client, but there is growing need for multi-DRM client builders who can really take that wrapper of trust and make it account for a whole lot of different DRM cores underneath and a whole lot of players at the top end and just bring all the glue together. And then you have the secure player that's actually doing the user experience. It's doing the ad insertions, doing the analytics. It's doing the million other things that bring the content experience to life. So there's decryption, there's trust and business rules, and then there's actual rendering. This is how messy the DRM ecosystem actually is. And I'm sure I've missed someone. You can skewer me outside the room, no worries. But you have DRM cores. PlayReady is from Microsoft, Widevine from Google, Marlin, which is a standard but is administered by Intertrust, VCAS from Verimatrix, Primetime from Adobe, and there are a number of additional DRM systems that are specialized for use in certain use cases. These are sort of the large 4 or 5. Then you have the multi-DRM services that come from a number of different vendors. Typically, they are either middleware providers or conditional access providers, secure media player providers, online video platform providers, end-to-end workflow providers. They are all beginning to handle multi-DRM. Some of them like some systems more than they like others. Those preferences will be there, but they can provide the coverage. You have the players, so these are player SDKs that if you are the do-it-yourself type, you would license, bring in-house, and then port from device to device. You have the web browsers, and that will become important in a second. You have the CE device vendors who are actually footing the bill for all of this, for better or for worse. They have the lowest profit margins, but they have the most to lose if they can't receive the video on their devices. So they're sort of squarely caught in between the licensing on the one end and the royalties on the other and the security obligations and all of that stuff. So be sensitive to their pain when you're asking them to do stuff. And then there's the silicon vendors who are really starting to play a critical role as you move forward. The more you have to rely on hardware, the more you rely on what the silicon vendors are implementing. At the same time, it's important for the silicon vendors to hear from the rest of the ecosystem what is important to them. So robustness requirements revisited. What happens when can and may break, right? You can decrypt, let's totally hypothetically, if you have a Widevine level 3 client and you have HDR content that requires level 1, what are you going to do? You could always say, sorry, can't play the client, find another device, or you can downgrade. So for HD content or HDR content, you needed a full trusted path. If all you have is a software client, you can always fall back to SD. So typically those content licenses are negotiated that way, but you just have to have your system set up to recognize that that's happening and move downwards. And so this is one of those rare situations where failure is absolutely an option. You will lose user experience, you will lose consistency, you may lose competitive advantage if somebody else is able to deliver HD to a device that you cannot deliver HD to. People will start to shift to that service, but failure is an option here. All right, so moving on to disruptions. The reason we're having this conversation now, and why I think it's important to start these types of discussions, is support for plugins and browsers is dropping. We talked about the pain of implementing secure players. It's just as painful for the browser vendors to implement plugin architectures on the millions of devices and all the hundreds of different form factors they're having to deal with. So Google's dropping support for what's called the Netscape plugin API. That's how a lot of us used to write secure plugins, secure DRM players for the browsers. Microsoft is ending support for ActiveX and Internet Explorer. That also means that Silverlight will not be natively supported in Internet Explorer anymore, and it also won't be supported in Edge. So the most common way of using PlayReady is going away on a number of systems. The most common way of leveraging other DRM systems is going away. As a consequence, Flash and smooth streaming are not going to be working in browsers by default. You can still write apps, and we'll look at a couple of different ways that you can write apps. But the traditional way of doing things is going to go away no matter what. DRM is a cost center for most vendors. We love to bash Microsoft and Google for doing brain dead stuff, for changing formats on us, for not maintaining backward compatibility. They spend a lot of money building and maintaining these systems. They really don't get any direct revenue out of it. So as much as folks try to keep everything in line, you can expect disruptions. You can expect disruptions to increase, and that generates problems for developers and manufacturers. That's why, again, you want to rely on a multi-rights DRM vendor to the extent you can. That's another drum I'm going to be beating over time. These guys know what's happening. They can outsource that complexity for you. So as far as you're concerned, you're just sending protected content out and let them deal with all the underlying complexities. I will say that most secure player vendors that I spoke with are saying that less than 5% of their users are currently using Dash. So there's still continuing development and investment in plugins. It's just being done differently than it was before. It's fine. You can continue to do this at least for another year or so, but moving down the line, you absolutely want to start to have a story for migrating towards Dash and the more consistent interfaces. It'll give you lower total cost of ownership over time. It will give you broader device reach over time. It's just the smarter way to do it, even though it's unfamiliar right now. So in this entire utopia of standards and consistency, and all the multipliers are going to go down to 1, I don't think any of us had quite expected the wrinkle that each browser has sort of, for better or worse, become paired with one DRM system. In some cases, it's one because they haven't implemented more. In some cases, it's one and only one, and it's non-negotiable. So you kind of have to deal with that too. And this trend was why we kind of put this entire talk together. We'll get to that. So Chrome is currently bound with Widevine, and you cannot access any other DRM through Chrome as it is shipped. Safari is bound with Fairplay. iOS in general is its own ecosystem. They do things the way they do it. So I think you can continue to see iOS as a silo, but at least a consistent silo where all of iOS works the same way. Microsoft Edge is bound with PlayReady. They're a little bit more open in supporting additional DRM cores. It just, you need those DRM cores to be implemented, and that's typically not the case. And then Firefox currently ships with Primetime. Again, you can build your own decryption module for Firefox, just people aren't really doing that anymore. The other thing to keep in mind is Widevine is not Widevine is not Widevine. There are different security levels of Widevine. There are different security levels of PlayReady. Different devices implement them in different ways. So if you're sending to Chrome and assuming Widevine will be present, that's great, but Widevine level 1 may not be present, and that may break your workflow. Go back to the slide where we said you can always go down to SD content, and that should typically work. All right, so keep those moving pieces in mind. Operators should be prepared to support multiple DRM systems. We're currently saying between 3 and 5 is what you should be expecting. It's still a lot less complex than building secure players platform by platform by platform. If Netflix is always the gold standard on how to bite the bullet and get on every device, but typically we will see budgets of anywhere between $1 million and $1.5 million, even for supporting just the basic set of devices. Having multiple licensing servers running is complex, but far cheaper and far more scalable, far more maintenance friendly over time. If you're a business who wants to work with a particular DRM system, this tends to happen not for content protection reasons, but for analytics reasons, or for billing integration reasons, or a number of other, just everyday business reasons. You're going to have to be very smart about how you leverage HTML5. It can be done. It has to be done carefully. Before I dive into this, are there any questions? Does anyone disagree? I get uncomfortable when no one calls BS on me. We're good? No questions? OK. All right, so this is where it might start to get controversial. And again, don't be shy about speaking up. But there are 3 ways, based on the surveys we've done and the technology we've looked at, that you can implement secure players. You can still do it as a native app. It's expensive. It's complicated, both to roll out and to maintain over time. If you have an upgrade, you have to rely on the users to actually download the upgrade, install the upgrade, especially if you have a revocation, it becomes very complicated. But you can get richer, more fluid experiences, and you have very strong control over how you're building it. If it's something like a set-top box where you control everything vertically integrated, this is a great way to go. If you're trying to install an app on a Roku or an Apple TV where you have absolutely no control over things, native apps can get a little bit dicey. So, it's a good option when the economics allow it, but in the long term, it may not be hugely scalable. Browser-based rendering is the exact opposite of that. You're just relying on the browser. It's great because the features are defined. There's only one way to do it. You send it out, but you have to send it out on a wing and a prayer, because not all browsers will implement things the same way. Not all browsers will implement things consistently. You will be sort of bound to the user's choice of browser. There have been cases where service operators have tried to say you must use Internet Explorer, then the PC doesn't have IE installed, then you try to install it, then you don't have admin rights, then everything breaks, then they call your tech support. You've lost profit margin, you have a very irritated user, you typically don't want to do that. And so given that you've got this one-to-one browser DRM binding right now, unless you have a fairly simplistic use case, I'm not sure that browser-based rendering in the short term is going to be a viable option. So what we're recommending is hosted web apps. It's a good blend of the two. What happens is you write the HTML5 on a website. You've got a manifest. It's a standard technology that gets translated into an app. You have to go through some hoops, but the browser vendors and the tech vendors are getting better about getting those workflows very streamlined, very consistent, very bug-free, glitch-free. And then you can, just your web page turns into an app by default. You update the web page, your apps all update. You're leveraging all the standard interfaces, and you tend to get the best of both worlds. I really like what Edge has done with the Manifold.js project and with the Cordoba extensions. You have very tight user interface integration. You know exactly what DRM system you're going to be using. It tends to give you the best of both approaches. So these are our recommended best practices, and I'm almost towards the end, so we'll have plenty of time for Q&A. If you're a browser vendor, just as a good faith plea, make it as easy as possible for vendors to wrap your browser into a hosted web app. I would ask for make it as easy as possible to put any DRM into your browser. I think that's somewhat unreasonable given the business considerations at work. But at least make it easy to do hosted web apps. For SoC vendors and for CE manufacturers, we're recommending that instead of doing one DRM, you strongly consider doing 2 natively integrated DRMs. If you're doing a smart TV, you have to do it anyway because Marlin and PlayReady are mandated by standard. Typically, you want to support Widevine anyway because of the level of support it has through the Android ecosystem. So look at doing 2. 3 starts to get a little bit expensive. 1, we believe in the long term, is not going to be safe for the brand. Because again, remember, the CE devices can last for 3 to 5 years. You don't know what content is coming down the line. You don't know what might get revoked. You don't know what devices might get bricked. So just keep your options open. And that's required for SoC vendors who will then get incorporated into the CE systems. For service providers, again, plan to support 3 to 5 DRM systems. You're going to have to deal with that at least. You can try to unify them as much as possible. A lot of that will depend on how proactive the SoC and the CE vendors are. So you have to get that evangelism in place. A lot of that evangelism is also being done by the DRM core vendors. We're trying to make sure that their ecosystem is as broad and diverse as possible. For DRM vendors, and most of them already know this, the trusted execution environment isn't infallible. For those CE device vendors who are implementing DRM on their own, it's great if you're using the TE, but it is possible to get malware into the TE. Make sure things are secure, even from an app hardening perspective, inside and outside. And it's absolutely critical to have a renewability strategy. So yes, it should be secure the day it's shipped, but plan for failure, plan for renewability. Try not to get the devices bricked, or try not to have them default down to SD, because in the long run, it's not good for the user. And for player developers, again, we do believe that for now, at least the hosted web apps are a good balance between the portability that you need in terms of getting across all these devices, in terms of consistent user experiences, so it behaves the same way on every single device, the rights to render the highest quality content so you don't have to fall back to SD, and just the overall general excellence of user experience. Before I move to conclusions, any questions?
Hi, Eric Rabb from Newline. I think one point on the C side is because of common encryption and that secure video path, there actually is a lot of reuse in handing off to that secure video path. So I think maybe one point is thinking of the DRM not as there's really the key management and rights management, then there's the secure video pipeline.
Yes.
And since those being are sort of really two separate, it's actually, once you get the secure video pipeline, was actually very expensive and hard to do. You can actually maybe layer on more DRMs in the C side without having it be too ridiculous in implementation costs, because a lot of it's reusing the pipeline.
Point. That's a good point. Yes. Yes. Thanks for bringing it up. You're right.
I have a question about music companies, not videos. I want to know if Spotify, Deezer, and RDO are thinking about in something different that uses only browsers and not application, not Flash.
I don't know. I can find out. If you give me your card, I'll get back to you on that. I do know that for iTunes, they're using similar ecosystems for both. And I also have heard that ad-based models have become more popular for music than the more typical subscription-based models. So overall, I would think that it's still going to stay app-based, because it needs to know who you are and what your playlists are in the context of how it's selling music. But I will get back to you on that. I don't know. Questions, comments? All right, so we'll just jump to conclusions then. We needed standardization, and it really was getting to a breaking point. So it's a very welcome development that we are able to now solve the expense and the complexity of getting consistent, secure playback. The consistency is important, the security is important, and the end-to-end playback workflow, all of those are important. The way that the system's been architected now, in contrast to a lot of the previous approaches, we really feel has the characteristics to actually be implemented, to be widely adopted, to achieve the industry-wide benefits that it's meant to enable. So it's different from ultraviolet, where you kind of hoped for an interoperable digital locker. These are technologies we really believe are worth the investment and the deployment. Whether it's the media streaming extensions, the EME, or the common encryption, they all enable huge strides forward in their own right. It's important to keep the can versus may in mind, though. Just because you have a DRM client doesn't mean that you'll be able to use it. Keep in mind again that it's a business relationship, it's a technological implementation, but it's a business relationship. Ultimately, what defines DRM is trust, and it's very, very hard to legislate trust or translate or mandate trust or standardize trust. We do believe there is misplaced confidence in the level of ubiquity that the standards will provide. Just because, again, you can leverage Widevine or you can leverage OMR, you can leverage a compliant DRM system does not mean you will be allowed to do so. It doesn't mean that it will be consistently available to do so. And so you have to, you have to plan for that. We're strongly recommending, and I think I've said this at least 3 times already, that you choose a multi-rights DRM vendor. They know when to use their own DRM system. They know when to leverage third-party DRM systems. They will be on top of any changes in protocols or regulations or restrictions or formats for you. From your perspective, then you're just using one DRM. All the other abstraction is hidden behind their API. For any well-implemented multi-rights DRM system, it's a much easier and a much more cost-effective partnership than trying to do each individual port and figuring out all the combinatorics on your own. And then I will emphasize that failure is an option. The UX will suffer, the consistency will suffer, but you can always fall back. And with streaming media devices today, for example, you really don't have a consistent availability of secure playback paths. So they do SD and they do 720p, and it's fine. For the next year or two, it's actually going to be fine. And so there's some time before everything has to work in perfect tandem. By the time you get 60 frames per second HD, by the time you're doing 4K, you absolutely have to figure it out. But in the meanwhile, there's time to take baby steps and experiment and move forward. The onus really is on the OEMs and on the browser developers and on the app developers at this point to collectively ensure the highest possible resolution. There will always be vested interests. DRM development is a cost center for most of the larger vendors, so they will protect their own revenue streams at some point. But as an industry, it's very important that all of us come together and at least enable consistency and try to minimize the need to fall back to SD to the extent that it's possible. Again, we will recommend that you look at least supporting 2 DRM systems. To Eric's point, it's going to get cheaper to put more and more DRM systems on there to the extent that they don't conflict each other or you don't inadvertently introduce insecure code into the T. That's a great way to go. So change is coming. The change is going to make things better. It is going to disrupt a lot of the traditional ways of doing business. That disruption is necessary in the long run for everyone's growth. As long as you plan and prepare now, we really think this is probably one of the best things to happen to DRM in a while. So that's all I had to share. I do want to acknowledge the time that a lot of folks took to talk with me. Many of the content owners we speak with choose not to be named, so you know who you are. Thank you. And if you ever have questions, comments, need resources, anything at all, please feel free to reach out to us. Thank you.